Hi students, today we are going to be starting a new unit on chemistry. We are going to continue on with our plastics project with synthetic materials, but we are also going to be learning about atoms and molecules. So we have learning target 1, which is you understand that all material in the universe and the earth is made out of atoms that are from the periodic table of elements and that each element has unique structures and properties. And LT2, which is I understand that the structure of an atom consists of protons, electrons, and neutrons. Let's get started. So we're going to relate this chemistry unit to our plastics project. So we're going to start with looking at some things about plastic. So plastic is made out of fossil fuels, which are made out of hydrocarbons. Hydrocarbons are made out of atoms. And so this picture shows how atoms make up these molecules, which makes up larger structures. Let's look at this more closely. What is an atom? So an atom is the smallest particle of matter, and there's many different types of atoms in the universe. In your body, you have many types of atoms as well. So these are some pictures and some examples of some atoms that are a part of your body. Everything in the universe, whether it's living or non-living, is made out of atoms. What are the different parts of an atom? If you were able to look inside of an atom, you would see something like this. In the middle, we have a nucleus, which is essentially made out of two different types of particles. The first type is called a proton. Protons are positively charged particles. And the second is neutron. Neutrons are neutral particles, meaning they have no charge. So usually the symbol 0 means neutral, and the plus is positive charge. Electrons are on the outside of the nucleus, and they are spinning around the nucleus, and the electrons usually have a negative charge. If you look at the size of an electron, you can see it's much smaller than a proton or a neutron. So let's talk about these different particles. If you were to compare how these protons and neutrons, how different they are in terms of weight, or not weight, I'm sorry, mass, you can see that protons and neutrons are heavier than electrons. So protons and neutrons are about the same amount of weight or mass, and we call this atomic mass unit. This is the actual mass. And then electrons are much smaller, and that you would need about 2,000 electrons for it to equal one proton. One atomic mass unit is a very small amount of grams, as you can see right here. Now let's talk about what an element is. An element is a pure substance that cannot be separated into simpler substances by chemical or physical methods. That means you can't separate out an element any smaller than its atom. The smallest unit of any element is an atom. So here's an example. Gold is a type of element, and gold is made out of only gold atoms. And if you look at a gold atom, they have a certain number of protons, they have a certain number of neutrons, and a certain number of electrons, okay? So if there's a different number of protons or electrons, it would not be considered a gold atom. It would be a different kind of element. So for it to be gold, it has to have a certain number of these subatomic particles. And when many gold atoms come together, that's when you get something like this. The periodic table of elements is a table that shows all the different elements of the universe. There's over 100 different elements that have been discovered currently, and this is a table that shows the different types. Let's look at how the periodic table is organized. So first, it's organized by groups. So a group or a family is organized in columns like this, and every single group has a specific number attached to it. You can see 1, 2, 3, 4. And basically, each element in the same group has the same number of electrons in the outer shell. And what we mean by that is every atom has electrons spinning around it, and the outer shell is the outer side of the electron cloud, and the number of electrons on the outside is the same for every single group member here. For the period is a row. Okay, so this is a period, and each element in the row has the same number of electron shells. And what we mean by that, you can see the same number of concentric circles around the, the nucleus. So you can see here, this is K. K is here, it's potassium. Potassium, as you can see, is in 1, 2, 3, 4th period. That means it should have 4 shells. 1, 2, 3, 4. There's 4 shells. It also is in group 1. That means it should have 1 electron in the outer shell, which it does right here. Okay, and that's why K is placed here. The periodic table also groups elements by its properties. So you can see the yellow represents metals, the purple are the metal alloys. Basically, metal alloys are a combination of metals and nonmetals. They have properties of both. Nonmetals are over here. They're usually gases. Okay, they're not metals. Now I'm going to show you how you can read each part of the periodic table. So if you were to zoom into one of these boxes here, you would see a lot more detail. First, you have the symbol. So this symbol here, the letter, it's usually 1 or 2 letters. It's an abbreviation for the actual name of the element, and this is the name underneath the symbol. So this is C for carbon. And then you have the atomic number, which is here. The atomic number is the number of protons in the nucleus. So the nucleus is in the center. The number of positively charged protons is the atomic number. So this carbon has 6 protons, as you can see here. And then down here is the atomic mass. The atomic mass is basically the weighted average of the masses of all the carbon atoms that exist. So some carbon atoms they all have 6 protons, but some of them might have a different number of neutrons, and we call those isotopes. So this is the average weight or mass. So this is kind of like how many of these particles are in the carbon atom. The mass number is the sum of the numbers of protons and neutrons. So here the mass number will be 12. Okay. So how are the atoms of the different elements in the periodic table different? So we just saw carbon right here, but if you look at any of the other ones, you can see each element has a different symbol, which represents the different names. Each atom has a different atomic number, so you can see hydrogen, helium, lithium, they all are numbered differently. They also have different atomic masses. Some atoms weigh more than others. So you can see oxygen is the heaviest atom out of all of these, and hydrogen is the lightest. And again, the atomic mass, which is the number here, tells you how much it weighs, how many protons and neutrons and electrons there are. Finally, let's talk about why we need to know the number of protons, neutrons, and electrons in an atom. So a lot of the chemical reactions and properties of an atom, of a substance, comes from the properties of the atoms that make it up. So to understand the structure of DNA and why it's shaped like this, you need to know what kind of atoms make the DNA and how the different particles or protons and neutrons and electrons interact with each other when they are together. Similar to chemical reactions. This is a reaction where you put sodium, which is an atom type of element, sodium atoms into water. It causes this reaction. Why is it happening? A way to understand it is to look at the structure of the atom. How many electrons does sodium have? And how does that interact with water molecules? And similar with this Mentos and Coke reaction. This picture shows you the structure of a certain type of molecule. And for you to understand why we're able to make this shape, you need to understand what atoms make it and how the electrons interact with the electrons of the neighboring atoms. And we'll get more into that when we talk about bonding, but this is just an example of why we need to know this information. And that's it.